Today I'll be showing you some calculations with this circuit, which I showed you how to assemble in a different video. We're going to start with the time on the flashes, which is determined by the RC time constant of the capacitor. And that is relatively simple. Let me get the camera zoomed in. There we go. That's relatively simple. It's just the T time in seconds is equal to the resistance of the circuit in ohms times the capacitance in farads. So that'll be T is equal to, we have a 1 kilo ohm resistor in series with a 10,000 ohm potentiometer, so we're going to figure out the max timing. So that's going to be 10,000 plus 1,000 is just 11,000, and then we can write that in scientific notation, which is 1.1 times 10 to the, let me see, times 10 to the 4th times the capacitance, which is 100 microfarads, and in farads that's 10 to the -4. So that makes it really easy to just multiply these together. When we multiply exponents, they add. 4 plus -4 is 0, so T is equal to 1.1 times 10 to the 0th power, which is just equal to 1.1 seconds. So our longest timing should be 1.1 seconds between each pulse, and that's about what we've observed. Next, we're just going to find the voltage drop across the potentiometer, and to do that, we're going to use the voltage divider equation, which is the voltage across resistor 1 is equal to the total voltage times the resistance of resistance 1, all of that over the total resistance. So we're going to do the total at max resistance. So that would be the total voltage is 9 volts, since we're using a 9-volt battery, times the resistance of at max is going to be 10,000 ohms, which is what it is at max resistance, over total. We found earlier that it is 11,000. And you can see that these ohms will cancel out, leaving us with an answer in volts. So we can just use the calculator on this one. That's going to be 9 times 10,000 divided by 11,000. And we have about 8.2 voltage drop. So the voltage drop across the potentiometer, which we're calling R1, is equal to 8.2 volts. Well, approximately equal to. And those are two simple equations we can do with this LED flasher circuit. Feel free to find and watch the other video, as it's pretty cool and we'll show you how to construct this. Thanks for watching.